Welcome to Economics Chapter 2. It's the Aplia homework assignment. So question 1 is about production possibility frontiers. I want to start by talking just a little bit about production possibility frontiers. What this shows is if you use your resources in this simple two-good economy, you can produce either cars or alfalfa. The bowed-out shape of the curve demonstrates increasing opportunity cost. So it tells us that as an economy shifts from cars to alfalfa, they first take the resources that are very good at producing alfalfa and not so hot at producing cars and shift those over to alfalfa. So they don't give up very many cars, they get quite a lot of alfalfa for that. By the time you get down to the alfalfa axis where you're producing close to 60 million bushels of alfalfa, you're shifting resources over that are not particularly good at alfalfa and are very good at producing cars. So you give up more and more cars for each additional bushel of alfalfa. So that's the bowed out shape of that curve. And that idea of increasing opportunity costs as you shift toward the axes, toward the extremes, turns out to be really important over the course of the class. Economies that are producing on the production possibility frontier, so right here along the line, those economies are producing efficiently and they're using all of their resources. If you're producing in here at D or C, you're producing inefficiently, you're not using all of your resources. And out here at A and B are places that you would like to be, but you don't have the resources or the technology to get out there yet. So this, by frontier, we mean that is the most that you can produce when you're producing resources as efficiently as possible. So E and F are the efficient uses of resources, D and C the inefficient, and A and B unobtainable. So go to the next slide. We've got A and B here as unattainable. They're beyond the production possibility frontier. C and D are inside the production possibility frontier. They're inefficient. And E and F are out on the production possibility frontier. They are efficient. Question 2 is a little bit more complex. So question 2 talks about opportunity cost and production possibilities. So again, we will have the concept of increasing opportunity cost as you move from one axis to the other one. In this particular example, we've got Kate, who has 8 hours a day, Simone, who has 8 hours a day to produce toys. She can produce 4 trucks and no kites. So if she uses all of her time to produce trucks, she can produce 4. If she uses all of her time to produce kites, she can produce 20. So the first piece of this assignment is simply to graph that. So point A, 0 and 4 would be right here. Point E, 0 and 20 would be right here. The next step of this question asks you, tells you to look at what Simone is producing, what combinations he's producing, and think about the opportunity cost. So I've pulled in the table again. So Simone is using combination D, so she's producing 1 truck per day. If she decides to increase from 1 truck a day to 2 trucks a day, she goes from 19 to 16 kites. So when she produces that extra truck, she loses 19 minus 16, or 3 kites. If she's at combination C, where she's producing 2 trucks a day, and she wants to move to 3 trucks, so she wants to move from 2 to 3, in kite she's going to move from 16 to 11, so she's going to lose 16 minus 11, or 5 kites per day. So as she moves along the production possibility frontier in trucks, she is losing more and more kites. That's demonstrating increasing opportunity cost. So it's increasing, so they're going from 3 to 5. The next piece of this problem is Simone has a new tool. She buys new technology that enables her to produce twice as many trucks per hour, but it doesn't affect her ability to produce kites. So you put a new graph on here, simply doubling the number of trucks. So instead of one truck, we're at 2 trucks. Instead of 2 trucks, we're at 4 trucks. Instead of 3 trucks, we're at 6 trucks. Instead of 4 trucks, we're at 8 trucks. So I just shifted out by doubling the number of trucks. So now she can make more trucks per hour. So her opportunity of cost of producing kites is going to be higher than it was previously. So she's going to lose more trucks, twice as many trucks, whenever she moves to a new point on her kite production curve. Then the last question here in this is normative and positive statements. Just looking at these to see if they're normative or positive. Positive means it's fact-based, it's provable, you can look up the data. Normative means it's opinion-based. So lung cancer kills millions of people each year. That's a positive statement, right? You can go check that and see how many people die from lung cancer every year. Too many people smoke. That's a normative question. You might think not enough people smoke. Lower our health costs overall. I think more people smoke, because they tend to die at a younger age. So maybe that's a good thing. You think not enough people smoke. That's entirely normative. If the government were to increase taxes on cigarettes, fewer people would smoke. That's true. That drives up the cost of cigarettes. You can check that. That's one reason we impose taxes on cigarettes, because it prices a few people out of the market. Then the government should increase taxes on cigarettes. Again, that's a normative statement. That's just opinion. You might think it's reasonable to tax cigarettes and convince people not to smoke that way, but you don't have to. But that's an opinion. That's not something that's provable. And that brings us to the end of the Aplia assignment for Chapter 2. So I hope you had a lovely time completing this assignment, and I'm excited to read your blogs on Chapter 2. Thanks. Bye-bye.